Hello and welcome to Strengths of Acids and Bases. Today we are going to look at how we measure the strength of an acid and a base, what the difference between an acid and a base is on the pH scale, and what that has to do with solutions. The pH scale. The pH scale is a measure of the concentration of hydronium ion. It goes from 0 to 14. 7 is neutral. 0 to 6 is the acidic part of the pH scale. 8 to 14 is the basic part of the pH scale. So that kind of gives us a number to put to how strong an acid or a base is. The lower the pH, the greater the concentration of hydronium atoms. Now remember back to the previous video, hydronium ion is H3O+, has an extra hydrogen on the water molecule. So we are literally going to measure the concentration of that ion. The higher the pH, the less hydronium ion. The lower the pH, the greater the concentration of the hydronium ion. The pH scale goes from 1 to 14. On the low end, we have the acids: battery acid, gastric acid, hydrochloric acid. Then we have some things that we've heard of: black coffee, acid rain, soda. Pure water is typically about a 7. Seawater is a little bit more alkali or basic. It has some different stuff in there that will cause that to happen. Baking soda, you've all probably worked with baking soda. That's also a base. And as we go up, milk and magnesia, ammonia, soapy water. We talked about this in the last video, I believe. That soap is made from lye, which is a base. Bleach, drain cleaner, Drano, very, very, very basic. As bad as battery acid is for you, Drano is also for you. So that gives you some common things that you've seen in your everyday life to kind of put into the pH scale. So let's talk about some of the stronger acids and bases. Strong acids dissolve in water. They ionize almost completely. Almost every single molecule of, let's say, HCl that you put into an aqueous solution, meaning a water solution, will dissociate or ionize into hydronium and chloride ions. Same thing with the sulfuric acid. This would be the battery acid, as well as nitric acid, just to name a couple of strong acids. Strong bases do almost the same thing, except they do it on the other end of the scale. They almost completely dissociate in water to form hydroxide ions. Calcium hydroxide and potassium hydroxide would be two examples. Almost every single one of these ionic compounds we put in dissociates to form a hydroxide ion. Weak acids and bases. Weak acids and bases dissociate only slightly in water. Not all of it will turn into hydronium or hydroxide. We can use weak acids and bases to make a substance called a buffer. A buffer is a solution that resists large changes in pH. These can be very useful for us if we want to create a solution that maintains a pH. For example, our blood has chemicals in it to maintain our pH. We don't want a really high pH, we don't want a really low pH, we want it to be maintained. So buffer solutions are very useful. Let's talk a minute about electrolytes. Now electrolytes, most of you have probably heard in one context or another. Electrolyte is a substance that ionizes or dissociates into ions when it's dissolved in water. They can conduct electric current. Strong acids and bases are strong electrolytes because they dissociate almost completely. Batteries contain electrolytes. Car batteries, this is why we use sulfuric acid, a strong acid, in car batteries. It's a very strong electrolyte. It conducts current very, very well. Another place you probably have heard of electrolytes, your body requires a proper balance of electrolytes in order to function properly. An example of this is Gatorade. Gatorade's high in electrolytes like potassium ion, sodium ions, maybe chlorine ions. That's very important in making your muscles function right. So electrolytes, very important, conduct electricity well.